Now let us move forward and see the last coordinate system, that is spherical coordinate system. As the name suggests, it deals with a shape which is very common and it is known as sphere. To make a sphere, you know that we need only radius and nothing else. Why? Because if you specify only radius, you have to move this radius everywhere on all the possible 3 dimensions, maintaining the length of the radius constant. If you rotate this radius in a plane on all the sides possible, you will get a circle. But again, in an orthogonal plane, if you move it, you will get another circle. In this way, you have to make many circles on the vertical plane to make a complete sphere. I hope you understand what I am saying. So, to make a radius, we need, to make a sphere, we need only radius and nothing else. But in electromagnetic theory problems, sometimes we don't require a complete sphere. Sometimes we need the section of a sphere, like this here. This is 1/8 portion of a sphere. If you cut a sphere, if you have a sphere, if you cut this with a knife vertically, then horizontally, only 2 planes are necessary to cut it and make 8 parts out of it. Means we are taking 8 pieces from a sphere. This is one of the piece only which lies in the positive quadrant. So to make this piece, let us understand what we need. To locate anything in a sphere, we need, first of all, we need a radius, right? But as I told you that only with the radius we can move on all the points on the surface of a sphere, but we cannot restrict its position. So in sphere, only r is there to tell you the complete radius of the sphere, but to restrict yourself on a point on the sphere, we have 2 angles. One is angle theta. This angle theta is known as polar angle and it tells us the angle between z-axis and this radius, this line which is showing us the radius r. And this theta, it has the maximum to minimum limit only 180 degree, means this radius can move only from this north pole to this south pole. And if you want to move some other side, you will have to move from again north pole to south pole, but in the same direction, like this, from top to bottom, right? So theta is the angle which gives us vertical motion from north to south, obviously angularly. But again, for example, we have located this on a vertical plane with the help of theta, but to locate this point in the horizontal plane, we again need the same concept that we used in rectangular coordinate system. We will drop this point we will drop this point P on the ground, and this ground is on XY plane. And once it is touching the XY plane, we'll draw a radius, a straight line which joins the origin. And this line, which is on the XY plane, if you draw an angle starting from X which goes till this line, this angle will be known as phi. And you are right, this phi is same phi as we saw in the cylindrical coordinate system. So if you have noticed that there is one dimension which is common between Cartesian coordinate system and cylindrical coordinate system, and there is another point which is common between cylindrical and spherical coordinate system. So phi is that common link between cylindrical and spherical coordinate system, because there and here in both the places it is telling us about azimuthal movement, azimuthal circular movement on the XY plane. So where this location, this method of locating point is used, let us see. It's very common. You all have studied geography. You know that in a globe we have something known as latitude and something known as longitude. So the latitude tells us that if you move horizontally on the earth or on the globe, you will locate some point on the same plane, on the same horizontal plane. But to exactly locate a point, we need longitude as well, and the longitude runs from the North Pole to the South Pole. So let's say we are considering this equator and this longitude. So the intersection of this equator and the longitude will locate any point on the globe. But we know that Earth has some high altitude points like mountains and some valleys which are way deep inside the ground. So for that we need what? We need radius. So radius, in this example, you can say that it is the distance from the core of the earth to the surface of the earth, and it can change at any point from plateau to mountains to valleys, anywhere, right? So this is the best analogy that you can get of to understand about spherical coordinate systems. So concluding my explanation, let us at last see what are the three limits that it can reach. The three limits that we can reach are, for radius, we have origin to infinity. As I have already explained earlier, a radius, because it always starts from a common point, from an origin, from a central axis, it will start from 0. Then we have two angles here this time. In rectangular coordinate system, we all have three linear dimensions. In cylindrical coordinate system, we had two linear dimensions and one angular dimension. In the spherical coordinate system, we have two angular dimensions and only one linear dimension. So what about these two angular dimensions? One is theta. It is known as polar angle, and as the name suggests, it runs from positive z-axis. For example, you can say it's north pole, and the negative z-axis, it is south pole. So if we say that this z is at theta equals to 0 degree, if we go straight down following this angular path of theta, we will reach 180 degree. So the opposite side of this positive z-axis is negative z-axis, and to reach there we need to move 180 degree, that is pi. And phi I don't need to explain, I think, because we have already understood in cylindrical coordinate system, to move a complete circle on the horizontal plane we need this complete movement, which is from 0 to 2 pi. That is how we need to understand all these three coordinate systems. Thank you. See you in the next video.